So satellite is a spacecraft communication system that enables the carriers to aboard a communication system in which the equipment is able to communicate from one end to another, but through the satellite link. So a satellite communication system is a spacecraft that carries communication equipment enabling communication between one point, enabling communication between one point to another. So when you look at this, generally satellite will be a kind of interconnection that's able to carry information on an equipment between one point to another. Then in satellite communication, we normally have laws of satellite. Communication. Basically, the communication between a satellite link is governed by what I refer to as Kepler's law. So satellite motion are basically governed by Kepler's law. Kepler's law. They are three. And namely, number one is Kepler's first law. For us to understand what Kepler's first law is that you have to understand the basic physics concerning motion of moving objects and how we can maintain them at a constant motion when it's moving in a rotating manner. So Kepler's first law, it states that the satellite will follow the elliptical path. It says that a satellite will follow. It said that a satellite will follow the elliptical path. Satellite will follow the elliptical path in its orbit. In its orbit around the primary body. Around a primary body. The primary body is the Earth's surface. Primary body is the Earth's surface. So if you were to sketch this, we shall sketch this as an Earth. We shall have the satellite orbit. This is what referred to as the satellite. This is the satellite orbit. So we're going to have Kepler's second law. It states that for equal time intervals, it states that for equal time intervals, the satellite sweeps out the satellite sweeps out equal areas. Equal areas. The satellite sweeps out equal areas in orbital plane. Equal areas in orbital plane. In orbital plane, the orbital plane refers to the area where it's now moving, the path in which it's moving. Orbital plane focused at the barycenter. Focused at the barycenter. Barycenter is the center of the Earth. This is the center of the mass of the body. So we're going to go to Kepler's third law. Kepler's third law. It states that the square of the periodic time, it states that the square of the periodic time, the square of the periodic time, square of the periodic time of orbit is proportional. Periodic time of orbit is proportional. Is proportional to the cube of the mean. Is proportional to the cube of the mean distance between the two bodies. The mean distance between the two bodies. We are going to have then some terms used in satellite communication. So we are going to introduce something referred to as terms and definitions. These terms and definitions are the common terms that any person who comes around the satellite communication system will be able to know. So the first time you're going to have here is a major axis. It's a major axis. This is the distance between the perigee and the apogee. The distance between the perigee and the apogee of an elliptical orbit. And for us to be able to figure this perigee, apogee, and the major axis well, then we need to understand how the diagram appears to be. So we are going to sketch this so that in our definition we can be able to relate and figure out. So let us sketch a bit of this so that we understand what this is. Latency, it is the signal propagation delay between Earth stations, This means that the time taken for the two Earth stations to communicate, the period that elapses for the two Earth stations to communicate, is what referred to as the latency. We're going to have a third term as footprints. From the term footprints are normally marks, and in these cases we also have footprints in satellites. So for us to have the footprint satellites refers to the area on the surface that is be able to receive the power. This refers to the areas on the Earth's surface that is able to receive power from the transmitter, that's able to receive power from the transmitter. So there are factors that determines the footprints, factors that determine the footprints includes Roman 1, the shape of the antenna. And Roman 2 is the height of the satellite. And lastly, Roman 3 is the orbital path. Then we're going to have a third term is the apogee. A fourth term. We have the apogee. From this diagram, we can be able to know what the apogee is. And therefore, it is the farthest distance from the Earth. It is the farthest distance from the Earth's center to the orbital path. So our last term that is very common with satellite is what I refer to as satellite keeping. This refers to the process this refers to the process of maintaining a satellite within the operation window. The routine involves north and south, reverse, north, south adjustments. Of north-south adjustments of the satellite to prevent north-south adjustments of the satellite to prevent deviation in latitude. So we can have additional terms that are normally accompanying satellites. We can have a term here as bore site. Bore site. That's from the term site on how we look at things. So this is the maximum direction. This is the maximum direction for the antenna, maximum direction for the antenna. To have its maximum gain. For the antenna to have its maximum gain. Another thing is that when we're using the satellite, we engage the frequency, and at times we have to use the same frequency that we had assigned. So we are coming to go with the term what I refer to as frequency reuse. Frequency reuse. Frequency reuse. It is the process of concurring. It is the process of concerning already used frequency remember the frequency is already used frequency which was allocated for already used frequency which was allocated for. So maybe the final thing can look at in terms of the terms is the look angle. Look angle. Look angle. Look angle refers to the direction in which we shall point the earth station antenna. This refers to direction at which the earth's station antenna is pointed for maximum propagation. There are two types of look angle. This include Roman 1 is azimuth angle. And Roman 2 is angle of inclination. Angle of inclination or angle of elevation. So I'm going to sketch this so that we can be able to differentiate the two. horizontal plane, and this is the satellite. This is the true north. This is the azimuth angle. Then you will have this angle of elevation.